Some people don't like videos with no audio track. Therefore, I make some noises. I hope you like it. Today we want to repair a switching regulator, like this one. The dirty paper is a good conductor for high voltages, and it may actually destroy your circuit. Therefore I use ceramic tiles for electrostatic sensitive devices. Use the rear side of a ceramic tile. It's a good insulator, but it does not accumulate electrostatic charges. The next thing you need, an isolation transformer. Our oscilloscope is connected to protective ground via the mains cable. The ground is on the ground clip of the probe. High voltage is on the parts of the power supply. So we have to break this loop somehow. The trick is to run the oscilloscope from an internal battery, which is normally placed here. But this battery is very expensive. They charge $300 to $600 for one battery. That's too much. Why not connect our own battery, a cheap 12-volt battery? Pin 1 is minus ground, pin 2 is not connected, pin 3 is a data port, I don't know really. Pin 4 is a 15-volt output for charging, for the internal charger. It takes 30 hours to charge the battery normally, but I don't use it. Number 5 is a 12-volt input, and I suggest to put in series a Schottky diode for protecting of wrong polarity. I do not know if there's an internal protection in the scope, therefore I add this extra diode. At the bottom you see the small black diode. It's a Schottky type. The scope takes about 1.8 amperes. You may want to use connectors so you can unplug the power lead. We connect the battery. Wrong polarity would not matter, the diode protects us. And here we go. You could install a battery charger inside the scope to charge the battery from the scope itself when it's again running on the mains. But I don't do this, I charge the battery externally. Now we are ready to do our repair work. We have floating ground and we have isolated supply voltage. And we are running the oscilloscope from a cheap standard battery which costs less than $300 or $600.